Welcome to the chapter on environmental engineering. This field focuses on protecting the environment by reducing waste and pollution. In this chapter, we will cover waste treatment, pollution control, and sustainability principles in environmental engineering. Waste treatment involves converting waste materials into more manageable forms through physical, chemical, and biological processes. There are three main types of waste treatment: physical treatment, chemical treatment, and biological treatment. Physical treatment includes processes like screening and sedimentation, which remove large particles from wastewater, and filtration, which separates solid particles from liquids. Chemical treatment involves neutralization, which adjusts the pH of waste to neutral levels, and oxidation and reduction, which are chemical reactions that break down hazardous substances. Biological treatment includes aerobic treatment, which uses oxygen-loving bacteria to break down organic matter, and anaerobic treatment, which uses bacteria that do not require oxygen to decompose waste. A typical wastewater treatment plant involves multiple stages: preliminary treatment to remove large debris, primary treatment using sedimentation tanks, secondary treatment with biological processes, and tertiary treatment with advanced filtration and chemical treatment to remove remaining contaminants. Pollution control involves measures to reduce or eliminate the release of pollutants into the environment, including air, water, and soil pollution control. Air pollution control methods include scrubbers, which use liquid to wash unwanted pollutants from a gas stream, electrostatic precipitators, which remove particles using electrical charges, and catalytic converters, which reduce harmful emissions from vehicles by converting pollutants into less harmful substances. Water pollution control methods include oil-water separators, which remove oil from water, activated carbon filters, which absorb organic pollutants, and constructed wetlands, which use natural processes involving wetland vegetation, soils, and their associated microbial assemblages to improve water quality. Soil pollution control methods include bioremediation, which uses microorganisms to degrade pollutants, phytoremediation, which uses plants to absorb or break down contaminants, and soil washing, which uses water or solvents to remove contaminants from soil. To manage air quality, environmental engineers use the formula C equals E divided by Q, where C is the concentration of the pollutant in the air, E is the emission rate, and Q is the flow rate of air. This formula helps calculate how concentrated pollutants will be in the atmosphere, and it is critical to keeping pollution levels within safe limits. Sustainability in environmental engineering involves designing systems and processes that meet present needs without compromising the ability of future generations to meet their own needs. Key principles include reducing, reusing, and recycling materials, improving energy efficiency, and utilizing renewable resources. A sustainable building design might include energy-efficient lighting and appliances to reduce energy consumption, green roofs to provide insulation and reduce stormwater runoff, and rainwater harvesting systems to collect and reuse rainwater for non-potable uses. Life cycle assessment, or LCA, is a tool used to assess the environmental impacts of a product or system throughout its life cycle, from raw material extraction to disposal. The LCA process involves defining the goal and scope, conducting an inventory analysis, evaluating the environmental impacts, and interpreting the results to make informed decisions. For example, the LCA of a plastic bottle includes raw material extraction, such as oil extraction and refining to produce plastic, manufacturing, which involves energy and materials used to produce the bottle, distribution, which covers transportation to retailers, use by the consumer, and end-of-life options like recycling, incineration, or landfill disposal. Thank you for watching this chapter on environmental engineering. By understanding and applying these principles, environmental engineers can develop solutions that protect the environment and promote sustainability.